Hi, I am Raghavan, Chemistry Faculty from ALPHORES College. I invite you all for the ALPHORES Chemistry e-learning classes. Today's session is 39th. Okay, in this session, now we are going to discuss about the general properties of alkaline earth metals, that is S block elements. Alkaline earth metals, general properties of we have alkali metals. S block elements only, it is alkali metals. Alkali metals, not alkaline earth metals, it is alkali metals. That is 1A group elements. Okay, 1A group elements. 1A group. Okay, in the last session we have done some properties like electron configuration we completed, then properties such as atomic radius is completed, ionization energy, electronegativity, electron gain enthalpy, flame test, and oxidation states we have done, and hydration energy we have done. Okay, so the general properties we completed. So now today, after the general properties, now let us see, we have taken in the last session, that is nature of oxides, the oxides of alkali metals, that is lithium oxide, sodium oxide, potassium oxide, rubidium oxide, cesium oxide, that is alkali metals forms, that is M2O type of monoxides we completed, that is Li2O, monoxides we completed in the last session only. Okay, that is Li2O. Next one, monoxides, Li2O. Next one, sodium monoxide, Na2O, sodium oxide, that is next, potassium oxide, K2O, rubidium oxide, Rb2O, and cesium oxide. So all these are the monoxides. Okay, that is alkali metals can form, that is M2O type of oxides that we completed. So how we can prepare them? It is very easy to prepare them. Okay, so that is when alkali metal is heated in air, heated in presence of oxygen, okay, limited amount of oxygen, okay, when heated in limited amount of oxygen forms the corresponding oxide. It forms the corresponding oxide. See, the peculiarity of lithium when burnt in air, it forms lithium oxide, and lithium can also burn with nitrogen present in the air. Lithium can form lithium nitride, Li3N, okay, Li3N, it can form like this. When lithium element, when burnt in air, it can react with both oxygen as well as nitrogen and forms the corresponding oxide and nitrides. That is the special property of the lithium. Okay, so next, the rest of the alkali metals when burnt in limited amount of oxygen, that forms sodium oxide, that is potassium oxide, rubidium oxide, and cesium oxide. When the burnt alkali metal burnt in limited amount of oxygen gives the corresponding monoxides, that is oxides. Okay, that is oxides. We completed that oxides. So what is the nature of the oxides? Metal oxides are always basic in nature. So therefore, sodium oxide, that is lithium oxide, Li2O, sodium oxide, Na2O, potassium oxide, K2O, rubidium oxide, Rb2O, cesium oxide, Cs2O. These are all oxides. Okay, in these oxides, first one, solubility property. Solubility of the oxides from top to bottom increases. Solubility increases. Next, basic nature, that is basic nature of the oxides increases from top to bottom. Basic nature increases. Solubility increases. Lithium oxide is less soluble, okay, due to higher lattice energy. Okay, so from top to bottom solubility increases, basic nature of the oxide increases. So cesium oxide, it will be the strongest basic oxide among all them. Okay, among all of them, cesium oxide will be the strongest basic nature. Okay, that is the monoxides we completed. Right, now coming to the next series of oxides, that is alkali metals. In addition to the monoxides, they also form peroxides. Okay, alkali metals can also form peroxides. alkali metals can also form M2O2 type of peroxides. M2O2 type of peroxides. M2O2 type of peroxides, where the oxidation state of alkali metal atom is +1 and oxidation state of oxygen atom is -1. And remember, what is mean by a peroxy bond? O single bond O is called peroxy bond, where oxidation state of oxygen atom is -1. Oxidation state of oxygen atom is -1. Okay, so this is peroxides. They form M2O2 type of peroxides. Yes, and peroxy bond is like this. O single bond O is called peroxy bond, and oxidation state of oxygen atom is -1 and -1. Okay, so next, what are the alkali metals can form this type of oxides? Except lithium. Due to small size, lithium cannot form peroxide. Then, so sodium can form peroxide, that is sodium peroxide. Potassium can form potassium peroxide. Okay, then rubidium can form rubidium peroxide, and cesium can form cesium peroxide. Okay, except lithium, the rest of the alkali metals can form peroxides, stable peroxides. The rest of the alkali metals can form stable peroxides. What is oxidation state of alkali metal atom in the peroxide? It is always in any compound they are +1. Okay, and in peroxy bond, so oxidation state of oxygen atom is -1. Okay, in the peroxy bond, oxidation state of oxygen atom is -1. And another point is what is the formula represents peroxide? Oxide formula, we know that O-2, this is oxide. Next, what is a peroxide? O2 -2. O2 -2. What is the formula of superoxide? O2 -1. Sometimes it is important. Which among the following represents superoxide? Which among the following represents peroxide? Like that you can expect a questions. Okay, so you should be very careful. So because in inorganic chemistry chapters, so you have to be very careful from the corner points. Okay, all the simple concepts are important, right? So these are the peroxides. So preparation of peroxide, when sodium metal, when alkali metal burnt in excess amount of air, excess amount of oxygen, burnt in excess amount of oxygen at about 300 degrees Celsius, 360. Okay, so when alkali metal, when burnt in excess amount of air, okay, that is more amount of oxygen, or you can say excess amount of air, so it gives the corresponding peroxides. When alkali metal reacts or burnt in excess amount of air, gives the corresponding peroxides. Okay, limited amount of oxygen gives oxides, monoxides, and in excess amount of oxygen it gives peroxides. Sodium peroxide, potassium peroxide, rubidium peroxide, cesium peroxides. Okay, so peroxide, that is first step. What are the elements can form peroxides? Except lithium, rest of the elements can form stable peroxides. Why lithium cannot form stable peroxide? Because due to small size, lithium cannot form stable peroxide. The rest of the alkali metals can give the peroxides. How we can prepare? Second point, how we can prepare the peroxides? When alkali metal, when burnt in excess air, forms the corresponding peroxides. Okay, so what are the elements forms peroxides? Done, first point. Second point, how we can prepare their peroxides? Example, one more example let us take. Potassium can burnt in oxygen, excess amount of oxygen gives potassium peroxide, like this. That is formation of peroxides is done. Okay, now the properties of these peroxides. What are the properties of these peroxides? Let us say, for example, stability of the peroxides. Stability increases from top to bottom. 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 Solubility also increases from top to bottom. Solubility also increases from top to bottom. Okay, so stability increases from top to bottom, solubility also increases from top to bottom. That is the importance of the peroxides. And another important property of the peroxides, coming to the very important property of peroxides. Okay, that is sodium peroxide is used in submarines as air purifier. Very important point for EAMCET, and that is objective point of view. Sodium peroxide is used as air purifier. That means the sodium peroxide Na2O2 molecule is used as air purifier. Means what? It absorbs carbon dioxide and liberates oxygen gas. By absorbing carbon dioxide, it can produce oxygen gas. Okay, so let us write. So it is sodium carbonate is formed, Na2CO3 plus O2 gas is liberated. O2 gas is liberated. Balance it. Make it 2. Yes. 2. Yes, now it is balanced. 2 to the 4 oxygen atoms are there. 4 plus 4, 8. So it is 2 3 is 6 and 2 oxygen atoms. It is O2 is liberated. The important property. Remember, peroxides are used as air purifiers. Where they are used in air purifiers? That is used in submarines. So because they absorb carbon dioxide gas and liberates oxygen. Important property. Okay, that is sodium, that is peroxides are used as air purifiers. By absorbing carbon dioxide gas, they liberates oxygen. Okay, that is one important point. Okay. Next, the monoxides and peroxides are diamagnetic. Now coming to the superoxides. Superoxides of alkali metals. Superoxides of alkali metals. The superoxides formula is MO2 type of superoxides. Okay, in this MO2 type of superoxide, oxygen is always exhibiting -1/2 oxidation state. Should not forget it, very important. Okay, so superoxide, oxide formula is O2 minus 1. O2 minus 1. That means on the 2 oxygen atoms, the total charge is -1. The contribution for each oxygen atom is -1/2. Okay. So what is oxidation state of oxygen atom in the superoxide? It is -1/2. Okay. You should remember that. So oxidation state of oxygen atom in the superoxide is -1/2. Right. Now, superoxides. What are the alkali metals can form superoxides? Lithium, sodium, potassium, rubidium, cesium. Except lithium and sodium, potassium can form stable superoxide, rubidium can form stable superoxide, cesium can form stable superoxide. Okay, so except lithium and sodium, potassium, rubidium, cesium can form stable superoxides. Stable superoxides. And same, the stability increases from top to bottom. Stability increases from top to bottom. Solubility also increases from top to bottom. And another point, all superoxides are paramagnetic in nature. Important point. All superoxides are paramagnetic. All superoxides are paramagnetic in nature. Okay, all superoxides are paramagnetic in nature due to the presence of unpaired electron. That means single electron. All superoxides are paramagnetic in nature due to the presence of unpaired electron. Okay, that is very important point. So that is about superoxides. What are the alkali metals can form? Monoxides. All alkali metals can produce monoxides. What are the alkali metals cannot form? Peroxides, except lithium. Lithium cannot form peroxide. The rest of the alkali metals can form stable peroxides. What are the alkali metals cannot form superoxides? Lithium and sodium cannot form superoxides. Lithium and sodium cannot form superoxides because the superoxide, the size of these elements much smaller to form a superoxide. Okay, only large cations can form superoxides. Okay, large cation can form superoxides. The size of this O2 minus 1 is equal to the size of potassium cation. So therefore, the stable ions can form stable compounds. Okay, that is, lithium and sodium cannot form superoxides because their ionic size is smaller to form the superoxide. So potassium, rubidium, cesium metals can form stable superoxides, and they are paramagnetic in nature due to the presence of, you can say, unpaired electron or odd bond electron. Okay, unpaired electron or odd bond electron. Okay, that is superoxides. Okay, next one is, so oxides now completed. Next, let us take up reaction with water. What happens when reacts with water? Alkali metals, what happens when they react with water? Reaction with water. Alkali metals, reaction with water. Reaction with water, yes. Reaction with water, yes. What is the reaction with water? See, for example, alkali metal, sodium hydroxide, sodium oxide. When sodium oxides, okay, when sodium oxide reacts with water, what happens? H2O reacts with water, forms, it forms sodium hydroxide. It forms sodium hydroxide. So that is, when oxides dissolve in water, forms the corresponding sodium hydroxide. That is, oxides when dissolve in water forms the corresponding sodium hydroxides. That means, so these are the metal oxides. When metal oxides when dissolve in water, when metal oxides dissolve in water, so it forms sodium hydroxide. That is a basic, this indicates that basic nature of the oxide. Suppose if the metal is dissolved in water, sodium metal is dissolved in water, then it forms sodium hydroxide and liberates hydrogen gas. And liberates hydrogen gas. Yes, balance it. 2. Yes, 2. Balanced. So when alkali metal dissolves in water, the reaction is highly exothermic and explosive and liberates hydrogen gas. Okay, so oxides when dissolve in water forms sodium hydroxide. That indicates basic nature of the oxide, and the same nature, basic nature element when dissolve in water also can produce the same hydroxides. That indicates what is the nature of the element. It is basic in nature. Okay, so now as a result, see, alkali metals are very reactive towards water. They have great affinity for oxygen. That is why, so the reaction of alkali metal towards water is highly exothermic reaction. That is, all alkali metals, that is, the reactivity of lithium is slow, very slow reaction of lithium towards water. So that is sodium, potassium, rubidium, cesium, they vigorously reacts with, explosively reacts with water, okay, and forms the corresponding hydroxides. They form corresponding hydroxides and liberates hydrogen gas. Okay, one thing again, lithium, mild, very weak reaction towards water. So lithium slowly reacts with water. The reaction is not vigorous. Okay, it is mildly react with water, whereas sodium, potassium, rubidium, cesium, they react with water vigorously. And form sodium hydroxide, and due to the liberation of hydrogen gas, see, when a piece of sodium is dropped in water, small piece of sodium, when it is dropped in water, it burns, it catches fire and burns. Why it catches fire and burns? Hydrogen is a flammable gas. Since the hydrogen gas is liberated, so, and the reaction is highly exothermic, so the heat liberated in the process and hydrogen gas is liberated, so hydrogen gas absorbs the heat and burns. So that is the process. Okay, so that is when alkali metals, except lithium, when alkali metals reacts with water, forms sodium hydroxide and liberates hydrogen gas. Due to the liberation of hydrogen gas, and the reaction is highly exothermic, so it gives a flame. Okay, so the reaction is highly exothermic process. That is the reaction of alkali metals towards water. Okay, that is lithium. What about lithium? Lithium with water, we can write like this, but the formation of lithium hydroxide is less and the liberation of hydrogen is also less. Okay, the reaction of lithium towards water is less vigorous compared to the other alkali metals. Okay, that is the point. Reaction towards water. Okay, you should remember that. See, except that is lithium slowly reacts with water. We can say like this: lithium slowly reacts with water, but rest of the alkali metals vigorously reacts with water and liberates hydrogen gas, and the reaction is highly exothermic and explosive reaction. Okay, that is the reaction with water. Next, reaction with hydrogen. Next, reaction with hydrogen. Next, reaction with hydrogen. How alkali metals reacts with hydrogen? How alkali metals reacts with hydrogen? Yes, hydrogen. Yes, hydrogen. So what happens when they reacts with hydrogen? See, when a metal reacts with hydrogen and forms the corresponding hydrides, so alkali metals when reacts with hydrogen forms the corresponding hydrides. Lithium with hydrogen forms lithium hydride. Similarly, sodium with hydrogen forms sodium hydride. Potassium with hydrogen forms potassium hydride. Okay, and rubidium with hydrogen forms rubidium hydride. Okay, similarly, cesium also reacts with hydrogen, forms cesium hydride. Let us balance them. Okay, so it is 2 potassium, 2 rubidium, 2 cesium, it also forms 2 cesium ions. Okay, alkali metals reacts with hydrogen. Forms the corresponding metal hydrides. They give corresponding metal hydrides. Okay, metal hydrides. What is the nature of the metal hydride? So, metal atom, it is alkali metal atom, it always exhibits only +1, and the hydrogen atom exhibits -1 oxidation state. Important point to be noted. Okay, in metal hydrides, oxidation state of hydrogen atom is always -1. Okay, generally in all other cases, hydrogen always exhibits +1 oxidation state. But in metal hydrides, hydrogen exhibits -1 because hydrogen atom is more electronegative than the metal atom. So that is why hydrogen can acquire negative charge. Okay, so metal hydrides, hydrogen exhibits -1 oxidation state. Therefore, so metal hydrides are ionic in nature. They are ionic in nature. Remember that another point. Metal hydrides, hydrogen atom exhibits -1 oxidation state and the metal atom exhibits positive +1 oxidation state. Okay, so as a result we know that so all metal hydrides are ionic in nature. So that means lithium hydride, sodium hydride, potassium hydride, rubidium hydride, cesium hydride. Yes. So which is more ionic and which is least ionic? It is reaction with hydrides. Reaction with hydrogen gives the corresponding metal hydrides. So we have lithium hydride, Li plus 1, okay, Li plus 1 and H, lithium hydride, and cesium hydride we have cesium hydride. Okay, so H minus 1, cesium is plus 1. So which is more ionic and which is less ionic? According to the Fajan's rule, so hydrogen is common in all of them. Hydrogen is common, hydride, H minus ion is common, so they have the same size. So next, the nature of the molecule, the nature of the bond is based on the size of the cation. According to the Fajan's rules, that you will study in chemical bond chapter. Okay, according to the Fajan's rules, larger the size of cation favors more ionic. Again, larger the size of cation favors more ionic. Okay, that means cesium is larger cation than lithium. Therefore, lithium hydride is more ionic. Okay. Now, smaller the size of cation, smaller the size of cation favors less ionic. Less ionic means what? More covalent. Less ionic means more covalent. That is, it is less ionic means more covalent. It is more ionic and it is more covalent means less ionic. Less ionic. No doubt they are ionic compounds only. So they are ionic in nature. So from top to bottom, ionic nature of the hydride increases. Ionic nature of the hydrides increases. That is another point. Okay. That is reaction of alkali metals towards water is completed and reaction of alkali metals towards hydrogen is completed. Okay. Now that is hydrides are also completed. Reaction of alkali metals with oxygen done, completed. They form oxides, peroxides and superoxides. Reaction of alkali metals with water, that is also completed. They form hydroxides and liberates hydrogen. Okay, the reaction is highly exothermic and explosive. Next, reaction of alkali metals with hydrogen forms hydrides. In the hydrides, hydrogen exhibits -1. Okay, and these hydrides are ionic in nature. From top to bottom, ionic nature of the hydrides increases. Okay, so that is we complete. Next, reaction of alkali metals with halogens. Next, reaction with halogens. What are halogen elements? Halogen elements are 7th group elements. 7th group elements. That is fluorine, chlorine, bromine, iodine and astatine. Okay. Let us write reaction with halogens. Reaction with halogens. Reaction of alkali metals with halogens. Okay. What is the reactivity of halogens? Reactivity of halogen. Okay. Reactivity of halogens. Reactivity of halogens. That is, fluorine vigorously reacts with fluorine reactivity greater than chlorine. Chlorine greater than bromine. Bromine greater than iodine. That is the reactivity of halogens. So this is the reactivity of halogens. Okay. What is the reactivity of alkali metals? Reactivity of alkali metals. Reactivity of 1A group elements. 1A group elements. Reactivity of 1A group elements. From top to bottom, the reactivity of 1A group elements increases. That means lithium less than sodium, sodium less than potassium, potassium less than rubidium, rubidium less than cesium. That means cesium is vigorously reactive. Okay. So that is, this is the reactivity of halogens, and the reactivity of alkali metal with a particular halogen is like this. The reactivity of halogen is like this. Now, let us say that is, let us take up lithium fluoride. Okay, that is lithium fluoride. Fluorides of alkali metals. Let us write fluorides of alkali metals. Lithium fluoride, lithium compounds, lithium fluoride. Next, lithium chloride, lithium bromide and lithium iodide. These are all halides of lithium. Halides of lithium. Then halide, that is chlorides of, so in the group let us take chlorides. That is lithium chloride. Next one, sodium chloride. Next one, potassium chloride, rubidium chloride and cesium chloride. These are all chlorides of alkali metals. Okay, and these are the halides of lithium. Okay, so halides of all the elements, it is chlorides only we have taken. Now, okay, we should observe what is. See, we have similarly sodium fluoride, sodium chloride, sodium bromide, sodium iodide. Okay, so that is halides of different alkali metals. Halides of different alkali metals like this. And this is halide of a particular, that is particular halide. That is halides of alkali metals with particular halogen. Okay, now in this, let us see, according to the concept of Fajan's rules. According to the concept of Fajan's rules. Now, you should be very careful. See, in this case, so lithium is +1, lithium is +1, the cation is same, the size of the cation remains same, then anion is different. So, the nature of the molecule is decided by anion. Okay, anion. Now we have lithium fluoride and lithium fluoride to lithium iodide. Lithium fluoride to lithium iodide. According to the concept rule, according to the Fajan's rules, okay, that is, cation is common. Smaller the size of anion, favors more ionic. That means, according to the Fajan's rules, I am repeating. So that is, cation is common in all of them. So anion only can decide the nature of the molecule. So smaller the size of anion favors more ionic. Larger the size of anion favors less ionic. Less ionic means more covalent in nature. That means lithium fluoride is more ionic. And lithium iodide is less ionic. Less ionic means what? Less ionic in the sense it is more covalent in nature. So lithium fluoride is being more ionic in nature. Lithium fluoride is soluble in water, and lithium iodide is less soluble in water because it is less ionic in nature. Okay, it is less soluble in water. That is halides of lithium. Okay, now in the group if you take, okay, so lithium chloride, sodium chloride, potassium chloride, rubidium chloride, cesium chloride. So among the halides, what happens? So now here anion is common, and the nature of the molecule is decided based on the cation. Okay, so according to the Fajan's rules, larger the size of cation favors more ionic. Larger the size of cation favors more ionic. Okay, larger the size of cation means lithium plus sodium plus potassium plus rubidium plus and cesium plus. Cesium is a larger cation, therefore cesium chloride is more ionic than lithium chloride. From top to bottom, ionic nature of the halide increases. So among the halides, so that is lithium plus 1, lithium plus, then sodium plus, then potassium plus, rubidium plus and cesium plus. Once again, larger the size of cation favors more ionic. So therefore lithium plus is less ionic nature. Lithium plus is less ionic than, sodium plus is less ionic than, potassium plus is less ionic than, rubidium plus is less ionic than cesium. That means cesium cation forms more ionic compounds, more ionic in nature, and lithium plus is less ionic. You got it? So that is halides of lithium, fluoride, chloride, bromide, iodide, halides of lithium, and it is chlorides of alkali metals. Okay, so we have taken all the halides and we have taken all the alkali metals. Okay, so we explained that is lithium fluoride, lithium chloride, lithium bromide and lithium iodide. Okay, and ionic nature in the group from top to bottom. So ionic nature increases with increase size of the cation. Ionic nature increases from top to bottom with increase the size of the cation. According to the Fajan's rules, larger size cation favors more ionic. So therefore cesium cation favors more ionic. Smaller size cation favors less ionic. That means lithium cation is being smaller in size, so it is favor only for less ionic compounds, means predominantly more covalent. Less ionic in the sense what? It is more covalent in nature. That means lithium chloride favors more covalent. Okay, lithium favors more covalent. Now we have lithium, these are the lithium compounds. And coming to this, lithium fluoride is more ionic in nature. Lithium fluoride is more ionic nature, so therefore lithium compounds are soluble. That is, lithium fluoride is soluble in water. Okay, then the other halides are less soluble in water. They are soluble in polar solvent, that is organic solvents. Okay, they are soluble in organic solvents. So lithium fluoride is being more ionic, it is more soluble in water. The solubility of the other halides of lithium is less in water. They are soluble in organic solvents. Okay, right.